Okay, it's 1 o'clock, so let's go ahead and get started today. All right, good afternoon, everybody. How's everybody doing today?
Hey, Professor, I think we're all doing good, but we're tired.
Yeah, I get it. You know, I know you guys have been going through a lot of exams, and I know there's probably more exams to come, so it's definitely that time. So you know, even though everyone's tired, and I know everyone's lacking sleep, so I appreciate everyone that's coming out to the lectures, because it's even though it's not the same as in-person lectures, just seeing your names on that participants list, and for all I know, half you guys might be bots, but just seeing the people attending your lectures, it helps a lot. Because it's one thing to just kind of speak just to myself and just my empty apartment right now, but to know that there might be some people out there virtually listening to me is always nice. So I appreciate you guys coming out, and I appreciate you guys pay attention to the lectures and ask questions too. Okay. So let's talk about the exam first thing today. So I finished grading your exams Tuesday night, actually, but then there are a couple issues, and I think I posted the grades on Wednesday. So let's talk about the average first. The average was 43 out of 50. Okay. So pretty high. So you guys did pretty well. So that's a good average to me. I do want to address a couple issues, because it's I know that the wording on some of the problems on the exam was a little bit poor. Question 6, I think, was kind of the first one that people kind of told me about, which I think I used the word increased revenue, which we had seen before, but I think in the exam setting, it kind of seemed like it was a gradient. So I tried to address that, but I think there were still a couple people that took it as a gradient on the exam, but I've already kind of talked to the people. And I think the one that I've gotten kind of the most feedback on was question 2 on the exam. So question 2 was the question of if your business major friend comes and talks to you and he's like kind of talking crap about engineering, what do you say to him? So basically what I wanted you guys to write in that problem was kind of what we talked about at the very beginning of the class about why is it that we as engineers take something like a class like this, which is like engineering, which is economics and ethics, because it's very, very different from the rest of your classes. So what I wanted to get out of you guys was to kind of just explain, kind of in your words, why you think it's important to take economics and ethics. But I think I worded it in one of the most poorly, probably the most poorly worded way that I could have. So I know I've already kind of talked to a few of you guys privately about this, and we talked about regrades and stuff like that for half credit. But after thinking about it a bit more, I think what I'm going to decide is that if you miss points on that problem and you want to redo it, just send me an email about your revised response, and then I'll grade it for full credit again. So you can get up to the max 5 points for that problem if you send me your revised response. Okay. So I apologize for the wording of that problem. It's just to kind of peel back the curtain a little bit, because I know that taking classes virtually and even just taking classes in person too is kind of like a stressful thing. So I was hoping to write a question in a way that maybe add some just lighthearted flavor to it. But I think in the end it just caused way more confusion, and I think frustration in the end than I wanted. And that's never, of course, I can say that's never a goal of mine, but it's I think for the next exam and for everything now, I'll be a lot more clear in what I want you guys to write down, because I think that's going to be more important than any kind of laughs or anything like that. But I was telling people before the class though that reading some of your guys' responses to that question made me laugh quite a bit. So it's in what's been kind of an otherwise a pretty tough week for me, that was definitely a bright spot. So thank you guys for kind of rising to that too. But again, so if you miss points on that problem and you want to get a regrade on that, just email me your revised response, and I'll go in over the weekend and revise your grades accordingly for that problem, because I know I worded that very poorly, and that was a mistake of mine. Okay, so besides that, are there any other questions on the exam?
For the revised question 2, when do you need it by?
Sometime before this weekend. So I plan to basically do it on Sunday to do the revision. So if you can send me an email before Sunday, preferably like Saturday night, then I'll get to it, and then I'll revise your score.
Yeah. Okay, thank you.
Mm-hmm.
Wait, how would we know question 2 is the one that we missed points on? Is it broken down
Right. So if you go you go back to the link of the exam on Canvas, you should be able to see all your responses, and then it'll see the number of points that you got for that question, and also the feedback that I gave you on that question too. So if you go back to the exam, see that you missed some points on problem 2, you can send me your revised response, kind of based on the feedback that I gave you, and kind of what we just talked about just. Yeah. So the question. So the question in the chat is Discord okay? I would prefer email just so it's all in one place. But if you do on Discord too, just kind of make sure to remind me on Sunday to do that too. Yeah.
So if I send you a revised answer, you gotta give me like the 5 points?
Well, I mean, you still have to get it right. I'm promising to regrade it, but it's but yeah, if you give me a 5-point answer, then I'll give you 5 points for the problem. Yeah.
Okay.
Mm-hmm. Yeah, don't just email me saying points please, and then you have to actually answer the question, and then I'll give you the points for it. Yeah. Okay. Any other questions I can answer about the exam? If you haven't taken a look at the feedback, definitely take a look. And if there's anything that's confusing or you want to regrade for anything, definitely let me know. I'm always happy to discuss those things and discuss and either expand on my feedback or revise the score too. So I think that's a really important part of the instructional process. Okay. So there's no more questions. Let's go ahead and continue where we left off. Okay. So last time on Tuesday, we were talking about benefit cost ratio. So I know Tuesday itself was already kind of a tough lecture, and hopefully, I think if you kind of go back and kind of redo a lot of those calculations, should become a little bit more clear. But today we're basically going to be continuing on with benefit cost ratio. Okay. So to kind of recap, we've up to this point we've kind of covered 3 big categories of economic analyses, right? So we've gone over present worth analysis, we've gone over annual cash flow analysis, and we've gone over rate of return analysis. And so, those are the primary ones that we've gone over, but there's some other ones that you can do that are kind of, useful in certain niche situations. So benefit cost ratio is kind of one of those situations. Right? And so last time we kind of went over one of those, or just kind of what the basics of benefit cost ratio is. So let's talk about kind of an instance where this is probably more useful to you than like present worth or annual cash flow. Okay. Because usually when you compute benefit cost ratio, you compute it in this form. Okay. So you take the ratio of the positive cash flows in your problem and the negative cash flows. Okay. And so usually positive cash flows are things like revenue or like, from sales or things or money that the company makes. And negative cash flows are the costs that you pay out to either buy the materials, buy the machines, or whatever like that. So it's very much like a ratio of how much money that you're going to make for every dollar that you put into this project. But certain situations aren't exactly, this is not kind of the right way to think about some situations. Because this kind of makes the assumption that you're always doing projects that kind of make money, right? So if you work for like a private company, this is what's going to be the case most of the time, but there are a lot of jobs out there where, you're not going to be working for a private company. You might be working for a government agency or like a nonprofit or something like that, okay? And so for certain applications, it might be a good idea to revise the benefit cost ratio to be something more like this. Okay. And so you could have the ratio of like the benefits to the public over the costs to government. Okay. Because if you think of a lot of government jobs or a lot of public works jobs, like you think of the people that service the roads or that work on the traffic lights and stuff like that. The city or the state, they're not charging you to use a traffic light, and they're not charging you at least not directly to use the roads and all that stuff. So all these projects, you can kind of consider them to be public works projects. Okay? So public works projects, these are projects that are not going to be making your organization money, but it's going to provide a benefit to the public. Okay? So if you try to do the benefit cost ratio in kind of the traditional way, you're going to get something that's like, either 0 or like 1% or 2%, because you're not making money off the projects that you're doing. But where you can kind of quantify the benefits is saying, how much money are you saving for people by preventing crashes on the road, or by helping them get to their workplace sooner. So there's ways to quantify things in terms of the benefit that it provides to the public, and then you can divide that by the cost that it took to actually accomplish that project. Okay. All right. So let's do an example that kind of illustrates this. Okay. And so let's say that the city government wants to improve traffic flow by making more lanes at like a critical intersection. Okay. Okay. And so there's basically two options that it can consider. So you can either make more right turn lanes. So it can basically expand the road so that it'll have maybe a second right turn lane on the right. Okay. Or it can expand the road such that it makes more left turn lanes. So instead of maybe one left turn lane, there's two of them. Okay. And so let's write down the numbers for these. So each of these are going to have an initial cost. Okay. And so for the right turn lane, it's going to cost 8.9 million. And for the left turn lane, it's going to cost 11.9 million. All right. Okay. And so each one is going to cost a certain amount of money each year to maintain. And so for the right turn lanes, it's going to cost 150,000. And for the left turn lanes, it's going to cost 225,000. Okay. Another thing that it's going to another thing that's going to happen is that just by the sake of of doing construction on the road, it's going to cause some disruption to the public. Right? And so if you've ever come across an intersection where they're doing work, you know that they're going to have some lanes blocked off, and you might not be able to turn right and stuff like that. So that's going to cause some people to miss appointments and things like that. Okay? And so we can quantify this. So we can say that we can quantify this as kind of like another initial cost. Okay. And so for the right turn lane, since it's off to the right, this is going to cause an initial disruption of $900,000. Okay. But for the left turn lane, because that's more in the middle of the road, that's going to cause a disruption of 2.1 million. Okay. But after the project's complete, this is going to start providing an annual benefit to the public. And so this is every year. Okay? So this is annual. It's hard to fit. Okay. And so each year after the kind of the initial construction, each year the right turn lanes is going to produce about $1.6 million worth of productivity for the city. And then for the left turn lanes, it's going to cause $2.2 million of benefit for the public. Okay. All right. And so if we assume an interest rate of 10%, and then we set a time period of 5 years or 15 years, sorry. what we want to do is we want to use benefit cost ratio with this kind of modification that we have right here to determine which project is the best for the city to undertake, okay? And from a financial point of view. Okay, any questions on this? Okay. Okay, so just like we did before, we're going to compute the benefit cost ratio of each project individually. But since we're doing a comparison in between the two, in order to determine which one's better, we have to do our incremental analysis. So take the difference in between them, and then find the ratio for that. Okay. All right. But remember, because this is a public works project, the city's not going to be making any money off this. It's the public that's going to be benefiting from it. Right? And so on top right here, okay, we're going to have the benefits and the consequences to the public. Okay. Okay. Because even though the public's going to benefit, remember at first there's going to be some disruption because the construction is going to cause some additional traffic. Okay. And on the bottom here, we're going to do government spending. Okay. Okay. So let's compute this ratio for each alternative. Okay. So let's start with right turns. Okay. And so for right turns, we have this ratio here. And so we have two consequences to the public. Oh, how easy it is to collect tickets. Yes, yeah, that's another thing too. Oh, how would the city go about? Yeah, so that's a good question. So yeah, part of it is just increased tickets, but also if you have increased lanes, there would be less traffic and people can get to their places better. And there's some economic models that you can do to say, like, if people are getting through this intersection better, how many more appointments are there going to be? How many less crashes are there going to be? And that's kind of how they would quantify this thing. It's a complicated thing, but it's there's ways to kind of estimate the value of something like that. Yeah. Okay. And so for right turn lanes, we had an initial disruption of $900,000, right? And so we have increased traffic there. That's going to cost the city, that's going to cost the people about $900,000 in lost productivity. Okay. And then to this, we're going to add our benefit. Okay, so we have 1.6 million. Okay. And since this is an annual value, we're going to convert it to a present worth. So we have P over A, 10%, and 15. Okay. And on the bottom here, we're going to include the cost to the government. Okay. And so the government, even these are costs, just to make sure that our ratio is positive, we're going to turn these into positive numbers. So we have an initial cost of 8.9 million. Okay. Plus the maintenance cost. So maintenance is going to be 150K. P over A, 10%, and 15. Okay. And so we compute this. This is 1.122. Okay. And so since this is over 1, we say that this is a good investment. And so one way that you can think of it is that, for every dollar that the government's going to be putting into this project, the general public gets $1.12 worth of benefit from it. Okay? And so it's at least efficient in that way. Okay. And so let's do the same calculation for left turns here. Right, so for left turns, we have an initial disruption of 2.1 million. And then to this, we're going to add the annual benefit of 2.2 million. And then we're going to divide this by the cost for the government. So the initial cost for the left turn lanes is going to be 11.9 million, plus the annual maintenance, which is 225,000. Okay. And then we compute this, and this is 1.212. All right. And so since this is also greater than 1, this is also a good investment. Okay. Okay. And so both of these options are good, even when, especially when we consider the modified benefit cost ratio. But in order to find out which one's better, we need to do incremental analysis. Okay. And so we're going to take the difference in between these two guys and then find the benefit cost ratio for them. Okay. All right. All right. Any questions on this? Okay, and so remember, to perform incremental analysis, we're going to take the difference in between the cash flows. Okay. Okay, so we're going to do each of these individually. So we're going to take the difference of kind of the numerator of our ratio and the difference on the denominator. Okay, and so let's do the incremental effect on the public. And so we're basically going to take the two numerators from both of our previous ones and just simply add them together, or subtract them. So we're going to take the higher cost alternative minus the lower cost alternative. So our higher cost alternative here is the left turn lanes, and so we're going to take the left turn lanes, right? So I'm going to use a different color for that. Okay. So we have a minus 2.1 million, okay, plus 2.2 million, okay, P over A, 10%, 15, okay. And so that was our numerator for the left turn lanes, and then from this we're going to subtract the numerator from the right turn lanes. Okay. And so for the right turn lanes, let's just look back here. So for the right turn lanes, we have this minus 900,000 plus 1.6 million. Okay. Plus 1.6 million P over A, 10%, 15. Okay. And so we add these together, and then what we get is, or we perform the arithmetic, and we get is 3,364,000. Okay. And then now we're going to take the incremental effect on the government cost. Okay. Okay, so the incremental effect on government cost looks like this. Okay. And so we're going to do the same thing. So we're going to do the government cost from the left turn lanes minus the government cost from the right turn lanes. And so first we have 11.9 million. Okay. And to this, we're going to add the yearly maintenance, which is 225,000. P over A, 10%, 15. Okay. And then from this, we're going to subtract the government cost of the right turn lane. So this is 8.9 million plus 150,000 for the maintenance. Okay. And we add this together, and we get us 3 570,570,000. Okay. And now for the ratio, we're just going to take the ratio of these two guys. And then what we get is 0.942. Okay. And so since this guy is less than 1, what that tells us is that it's better to go actually with the lower cost option. Okay, which in this case is the right turns. All right. Okay. And so again, we get kind of an unintuitive result, which says that basically, even though by itself the left turn lanes produces a more efficient return on the investment for the public, if we invest in the right turn lanes, what we can do with that extra money. So if we invest in the right turn lanes, we have some extra money that we can work with. We can put that money towards other public works projects that are going to be more efficient for the public. So for this particular case, choosing between the right turn lanes and the left turn lanes, we can choose to invest in the right turn lanes. Then everything else we can put towards something else. Okay? Right? Does that make sense to everybody? Are there any questions on this? Okay. Okay. And so that's all I got on benefit cost ratio. So you can think of benefit cost as just kind of another alternative to like your rate of return analysis or your present worth or your annual cash flow. Okay? And so there's lots of other analyses are there. If you look in the notes, there's one on payback period. But because of the timing, I want to make sure I get into taxes a little bit today. And so I'm going to skip over payback period and we're going to do break even. And so even though I'm skipping over payback period in the lecture today, that means you won't be responsible for knowing it too. So if you're curious about what it is, you can definitely read up on it in the lecture notes. It's not too bad, but I'm not going to be testing you on it. I'm not going to be asking you any problems on the homework. It's basically just there for if you're interested in it. Okay. But break-even analysis can be helpful because it's kind of its own separate thing. Okay. Because up to this point, when we're doing these kind of economic analysis problems, we've kind of assumed that most of the parameters and cash flows are basically fixed. Okay. Okay. And then a lot of times, you're solving for something like a present worth, which is, a sum of all the cash flows. Or you're solving for like the rate of return, which is, interest rate. Okay. But a lot of times, you're using these economic analyses to make certain decisions. Okay. And a lot of times, the decisions that you make in these economic situations, they depend on one key parameter. Okay. And so that key parameter could be, anything. So if that parameter was say, let's say that, you're deciding whether you want to go out to eat today. Okay. And so, you're deciding between, you're going to either eat the food in your fridge or you're going to go out to a restaurant to eat something. Okay. And a lot of times that deciding factor is the price of the meal that you want to go out with. Okay. So you kind of say to yourself in your mindset, if I can get a meal, that's going to satisfy me for less than 10 bucks, I'm going to go out to eat today. But if the only things that I want to eat are more than 10 bucks, then I'm not going to go eat out. I'm going to eat it at home. Okay? And so that particular case, that key parameter there was the price of the food that you want, right? And so economic analyses are the same way. So a lot of times, whether you decide to invest in, a certain machine or to not, or to move to a new facility or to upgrade here. A lot of those hinge on just that one parameter. So the idea with break-even analysis is to kind of find the point or to find the value of the parameter that kind of tips the scale in one direction or another. Okay. 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 And so that's kind of the idea for break-even analysis. Okay. And so we're going to do an example just right now, and the example that I'm going to give is this idea of stage construction. Okay. And so the idea with stage construction is that if you want to build like a whole new facility, or you want to perform a significant upgrade, you can either I mean, nowadays most of the time they do it in stages, but depending on when certain facilities are needed, say like you're building a whole new research plant, or you're building a whole new factory for manufacturing something big. Okay. And so that facility is not going to be built overnight. Sometimes it takes years and years and years to build these facilities, right? And so the idea with stage construction is to say that should we spend the time and kind of build the whole thing right now, or should we do this in stages? We build one stage first, and then we wait several years, and we build the next stage, and we wait several years, and we build the next one after that. Okay? And these stage constructions, they often depend on how soon do we need certain facilities. Okay. And so the key parameter here is when, okay? Or how quickly. Okay. And so let's say for this example, we're gonna consider a certain project where there's two stages, where we can build maybe the first half of our facility first and the second half later, or we can build it all at once. Okay? And so what we end up choosing is going to depend on how soon do we need that second part of the facility. Okay? And so we can perform a break-even analysis with that key parameter. Okay. And so what we're going to say is we're going to solve for at what point do we need we need that new part of the facility? Do we choose whether to go one direction or another? Okay. Any questions on this? Okay. All right. So let's do this example. Okay. So let's say that we're building a facility. Okay. And you have two different options for construction. You can either just build it all now. Okay. And the cost for this will be $140,000. Okay. or we can do this in stages. So we can build stage 1 now. Okay. And so if we build stage 1 now, this is going to cost us only $100,000. Okay. And then after we build stage 1, then we're going to wait a certain amount of time. Okay. And the amount of time we'll just call n because it's something we're going to solve for. Okay. And then at year end, the cost for this is going to be $120,000. Okay. And so option 1 is spend $140,000 now, and option 2 is spend $100,000 now, wait n years, and spend $120,000 later. Okay. Okay. And so the idea with this is that since this is going to be such a large facility, we're only going to need stage 1 for a long time. Okay. And so even if you go with option 1 and you build the whole thing now, you can kind of think of it as like half the facility is going to be unused for for a certain amount of years. Okay. And the time that we need stage 2 is going to be given by n. Okay. Okay. And so what we want to determine is what value of n will this kind of tip us in one direction or the other. Okay. Okay. And so just kind of let's intuitively kind of talk about this problem. So let's say that we need stage 2 really soon. So maybe for the first year in the facility we're only going to use stage 1, but then after that year we're going to need stage 2 right away. So in that case we're going to spend $100,000 in year 1 or year 0, and then $120,000 just 1 year later. And so since that's quite a lot of money, so spending that much money in 2 consecutive years doesn't really make that much sense. So in that case, it makes sense to build it all now. But if you consider a situation where n is something like 20, right? And so you build stage 1 of your facility, but then you don't need stage 2 for 20 years, right? So that's a really long time. And so that $40,000 that you save initially, you can spend in it, you can invest that in a lot of other things, and you can easily make up that $120,000 that you're going to need in 20 years. Okay. And so there's something in the middle. So there's a certain amount of n where you can say that at this n, we basically have, it's basically economically equivalent to do either option, and that's what we want to solve. Okay, and so the only thing we need is just an interest rate. So let's assume an interest rate of 8%. Okay. All right. So does that kind of make sense to everyone? Does this this idea of break-even analysis and what we're solving for, are there any questions on that? So there's a question of, could you give a real life example on a project that would require stages? Yeah, that's a good question. I think probably I would say, this comes up most often for, companies that kind of deal with kind of very complex and very varied kind of manufacturing. So, say like your SpaceX or something like that, and say that, you have plans to build like a whole new kind of engine for a new rocket, right? Parking structures, yeah. Parking structures, that's a good one too. But so you need to buy a whole new facility, maybe say in the desert somewhere to manufacture all the parts and to construct the engines. Okay, but on the other side, you also have your fins team or people that design the wings of your aircraft they also need a new facility to build, to build their stuff. Okay, and so you can either build a whole huge facility in like the Mojave Desert that can do both the rocket engine and the wings at the same time. But if the wings team doesn't think they're going to need something for another like 10 years, then you can stage it and you can do it one way or another. Amazon warehouses, that's another great example too. So yeah, Amazon's constantly, looking for ways to, to save on costs. So, if they don't think they're going to need a warehouse for a certain amount of time, then they might do it in a staged way, such that they make it efficient now and then save money later. But it might be more efficient just to build like a huge warehouse right now too. So yeah, all really, really good examples. Okay. And so the way that we're going to do this is we're going to use, we're basically going to compute the present worth of both options. We're going to compute the present worth, set them equal to each other, and solve for n. Okay.
And the reason why we set them equal to each other is because that'll be our break-even point?
Exactly, right. Yeah, so their break-even point will be when their present worths are the same as the other. Okay, so let's do the present worth of option 1 first, because that's pretty simple. Okay. So option 1, we're just considering the initial cost, so it's going to be a minus $140,000. Okay. And then option 2 will be $100,000 today, and then a future worth of $120,000 whenever we decide to build. Okay. Okay. So let's go ahead and do that. So option 2, it's going to be minus 100,000. Okay. Minus 120,000, and it's going to be P over F, 8%. And we don't know n, so we're going to solve for n. Okay. And so we set these equal to each other. We have minus 140,000. Okay. This is equal to minus 100,000 minus 120,000 P over F, 8%, and n. Okay. Okay. And so we're basically going to be solving this the same way as rate of return, except this is a lot more convenient because we can just stay on the 8% table, and we're just going to go down the list. Okay. Okay, so let's start plugging in. Okay, so let's plug in n is equal to 5. Okay, and so at n is equal to 5, we get the following for the right-hand side. Okay? So I'm just going to compute the right-hand side, and we're going to find the point on which it equals 140,000. Okay, so for n is equal to 5, we get minus 100,000 minus 120,000 times 0.6806. Okay, and this is equal to minus 181,700. Okay, so that's too high, or that's not enough. Okay, so let's do n is equal to 10. Okay, so let's kind of jump up quite a bit. Okay, so the coefficient for this is 0.4632. Okay, and this is going to be minus 155, 600. Okay, so we're still not quite there. So let's try 20. Or actually, let's try 15. Okay, so at n is equal to 15, we get minus 100,000. Minus 120,000 multiplied by 0.3152. Okay, and this is equal to minus 137, 824. Okay, and so we shot past it a little bit. So we went, too low at minus 155, and then we've shot past it at 137. So let's try n is equal to 14. we get minus 100,000, minus 120,000, multiplied by 0.3405, okay? And this is minus 140,860, okay? So it's not exact. It's going to be hard to find something that's really exact, and you can certainly interpolate this if you want, but this is close enough to 14 to say that at about 14 years, okay, that's the kind of the break-even point at this. And so basically what we can say is that if stage 2, if we needed that 14 years or less, so let's say we need it in like 12 years or 13 years, then it's more efficient to just kind of build the whole thing first. Okay, but if we don't need this for 15 years, so 15 years and beyond, then it makes more sense to do it staged, so that you can do stage 1, and then 15 years later, 20 years later, you build stage 2, and then with that extra money, you can do a lot more things for the company. And a lot of things can change in 15 years too, so you might not even need it by then. Right? Okay, and just like we did with the rate of return, you can also do this graphically as well. And so in this particular case, it's pretty straightforward. You just plug in your P over F formula, and then you leave n as an unknown, and you plot it in MATLAB or Excel, and you just find the point where it crosses the x-axis. So that's certainly another way that you can do these problems too. Okay, any final questions on break-even analysis? Okay. Okay, so that concludes our lecture notes on the other analysis method. So we only just covered 2, and so we covered just the benefit cost and the break-even analysis. We just did that. And so from here on, we're going to kind of switch gears a little bit. So we're going to move away from kind of the economic comparisons and economic analysis that we've done, and kind of talk about more practical things. So the first thing we're going to talk about is taxes. Okay? Everyone's favorite thing to talk about, and everyone's thing that's it's worse than a game of Monopoly at breaking up friendships and families too. Okay? And so, if you're familiar with American history, I think it was Ben Franklin. He said that there are few inevitables in life, right? Okay. And so one was death, right? The other is taxes. Okay. But he forgot one more actually, which is understandable because they didn't have the Marvel Cinematic Universe there, and so the third inevitable is Thanos, obviously, right? I'm just kidding, right? We're basically just going to be talking about taxes here, right? And I'll admit that before I taught this class, or actually before I got hired here, I hated taxes because it always felt like they're always kind of adding more money or taking money away from my income. But now that my salary is paid by taxes, I have a much different attitude towards taxes. Taxes are okay. Taxes are they pay for very people that like to keep a roof over their heads and have food on the table. So taxes are good. Okay. And so taxes, if you're kind of familiar with it, it's a very, very complicated subject, and it goes very, very, you can go down deep in the rabbit hole about taxes. But we're basically just going to be covering the basics of taxes, or more importantly, what does taxes mean for businesses and for engineers. Okay. Okay. And so what we're going to be focusing on is actually income taxes. Okay. And so the idea with income taxes is that everyone basically gets taxed by the government on any money that they earn, right? So whether you're a company, whether you're an individual, any money that you earn through work, you have to pay a percentage of that to the government. Okay. And so again, this is true for individuals and businesses. Okay. But actually, not every single dollar, not every single cent that you make as an individual actually gets taxed, right? So if you're familiar with the idea of like a 401k retirement program, right? And so the idea with the 401k is that every year you make a certain amount of money from your salary, right? And so if you didn't put anything into your 401k, then the government would tax the entirety of that salary, right? So say you pay like 30% in taxes. So you make like $50,000, 30% of that is 15,000. So you'd pay $15,000 in taxes. But what you can actually do, and this is an option for both individuals and for businesses, you can deduct some money from the money that that you pay to the government. Okay, and that's the idea of taxable income. Okay. And so the idea with taxable income is this is the only money that the government has access to that they can actually apply taxes to. Okay? And so usually this is a certain portion of your salary or a certain amount or a certain percentage of the money that you make. Okay. Okay. And so for a lot of people and for virtually all businesses, the idea or the goal is to basically try to reduce your taxable income as much as possible, so that you make a certain amount of money, but if you make certain deductions from that money, then you only have to pay tax on a much smaller thing. Okay? And so the idea for this is that you can either the term that they use for this is deduct or expense money away from your gross income to reduce your taxable income. Okay. And so remember, your gross income here can be thought of as the total amount of money that you make in a certain time period, right? So most times it's a year. And so what you can do is you can actually do certain things to deduct away from that. So your 401k, I think, is the perfect example for this. So let's say that you make $50,000 a year and you contribute 10,000 of that to your 401k each year. Okay? And so what you do is you take your 50,000 minus the 10,000, and so you say that this $10,000 is going to go towards my retirement fund. Okay. And so what you have left after that is 40,000. Okay. And so you're in that case, your taxable income is only 40,000, and then you only pay taxes on that 40,000. So that $10,000 that you stash away for retirement, you didn't pay taxes on it, but you actually pay taxes for it later on when you take it out. But that's a whole nother story. Okay? And so all the time, for individuals and for businesses, you want to try to reduce your taxable income as much as possible so that you kind of end up with more money on hand. Okay? And I'll show you kind of, and we'll talk about how businesses actually do this for their operations. Before I do that, are there any questions on this? Okay. Okay, so let's come up with the formula for taxable income. Okay, it's not really a formula, but it's a good way to remember it. Okay, and so taxable income, the way that you can compute it is you first start with your gross income. Okay, and so gross income is just the raw amount of money that you make every year. So if you get a job and it pays X amount every year, that's your salary. That would be you input your salary right there. And so for businesses, what they can actually do is they can subtract things called their ordinary or necessary expenditures. And then from this, they can also subtract what's called the depreciation charges. Okay. And so I left kind of big gaping holes in there just so I can define each of those guys. Okay. So let's define each one. Okay. And so gross income, just like we said, is the total amount of money that you made by the company. Okay. Okay. And so that's typically in 1 year, or let's just take a year just for simplicity's sake. Okay. Ordinary and necessary expenditures will be things like paying employees for their salary, paying for materials, or paying for equipment. Generally, things that are somewhat either get used up really quickly or don't last more than 1 year. And so the money that your company is using to pay you, basically they can subtract that money from their income and to not have to pay taxes on it. Okay? And so the idea with that is, you know, the individual is already paying taxes on this. And so if you kind of do it both times, you're kind of double charging for the taxes. Okay? And this last charge is probably going to, this last thing here is probably going to be the subject for, you know, for the future, you know, probably next week, is this idea that, you know, when a company makes a large purchase, like they buy like a large machine or they buy a new facility that we've been talking about, you know, in the past few weeks, you know, they can also subtract that from their income as well. Okay? And so this will be like costs of large equipment that lasts more than 1 year. Okay. Okay. And so after you apply all these things right here, then you can finally apply the tax rate. Okay. And so I know things are different now because I wrote this these notes at a different time, but just for the sake of you know, first of all, simplicity, just so that we can kind of use the same numbers throughout, and you know, kind of think of a time when this was before. Let's assume that the federal tax rate, so the amount of money that the federal government taxes, is going to be 21%. Meaning that the amount of money that you pay in taxes to the government will be taxable, whatever you get left after taxable income, and then you multiply by 0.21. Okay. All right. So there's a question in the chat. So also wealthy individuals sometimes donate to write off their taxes. How illegal is that? I'm going to refrain from commenting on that. But you know, there's, like I said, taxes is extremely complicated, and I don't want to go too much into the weeds because it's you know. I just want to kind of limit this discussion just about kind of the basics of taxes, but whether it's right or wrong, or you know who's paying taxes and how much they should pay is you know, maybe we can talk about that in the ethics portion. But for now, we're just kind of talk about the numbers for now. So I would say table that, and then we can talk about that another time. Okay. So in order to get the taxes that you pay, you take your taxable income. Okay, and then you multiply it by the tax rate. Okay. All right, any questions on this? Okay. And so for now, so I think for today, we're going to focus on just the first two here. And then we'll talk about depreciation next time. Okay, so let's just do a simple example just to kind of illustrate, how to do these calculations. Okay, so let's consider the following cash flows for a company. And so we're going to do it for 3 years. Give myself a little more room. We have year 1, year 2, and year 3. Okay. Okay. And so each year we can quantify their gross income. We can also quantify how much they had to pay in labor. Okay, so there's also the amount that they pay in materials and maintenance. Okay. All right, so in year 1, let's say that they made $9,000 and they paid $2,500 in labor. Okay. And so materials, 500, and then maintenance is 350. Okay. In year 2, they earned $9,500. They spent $3,000 in labor, 750 in materials, and then 350 in maintenance. Okay. In year 3, they made $8,500. They spent $3,500 in maintenance. Materials cost was 400, and then maintenance was 350. Okay. And so let's simply just compute the taxable income for each year. And then after that, let's compute the amount of taxes that they paid. Okay. And so remember, so let's start with taxable income. So for taxable income, remember the way that we're going to compute that is we're going to take our gross income, so that's the total amount of money that we made each year, okay? And we're going to subtract, the labor costs, the material costs, and any of the maintenance costs, okay? And so we're just going to simply just, subtract these guys from the gross income, okay? All right, so let's go ahead and do that. So year 1, we have 9,000 minus 2,500 minus 500 minus 350. Okay, and so we have 5650. Okay. Okay. And so in year 2, we have 9,500 minus 3,000 minus 750, 350. Okay, and so this will be 5,400. Okay. And so in year 3, we have 8,500 minus 3,500 minus 400 minus 350, and this is 4,250. Okay. All right. So question. So do all corporations get taxed 21% regardless of their gross income? So there's tiers to it, of course. So I think the tax system that we have now, depending on how much money that you earn, you pay a certain amount of taxes. But this. So I took a lot of these examples from the textbook, and I think that textbook just assumed it was 21%. For all income levels. But just like for individuals, I think corporations also get taxed depending on how much they make. Yeah. Okay. And so to compute their taxes, we just multiply these numbers by 0.21. Okay. Okay. So for year 1, we have 5650 multiplied by 0.21. Okay. And then we get 1,186. 50. Okay. In year 2, we have 5,400 multiplied by 0.21, and this is 1,134. Okay. Year 3, I can squeeze in there. Is going to be 4,250 multiplied by 0.21, and this equals, what was it, 892.50. Okay. So a pretty simple example, but just to kind of, just put some numbers to kind of the concept that we were talking about before, where, you don't, companies don't get taxed on everything that they earn. So they can subtract things like the labor, the materials, and maintenance. And so these are pretty straightforward, but, you might have heard in the news about things like, Amazon paying like $0 in taxes last year. And so there's a lot of things that you can expense or you can deduct away from your taxable income too. And with kind of the e-commerce and like a lot of the digital stuff nowadays, it's getting very hard to kind of quantify that amount. And so a lot of these companies, they pay a lot of money from lawyers to kind of make cases for how much you can deduct for certain things. So it's extremely complicated. So it's but we're going to just cover kind of just the basics on just the idea of this and kind of the for sure things that you can deduct from your taxable income. Okay. All right. Any questions on this example?
Can you go back to the last page, please, real quick?
Sure.
Professor, I guess the last line after the word taxes, is that the multiplication symbol?
Yeah. So it's two parentheses, and then they're just multiplied by each other. Yeah.
Right. Thank you, Professor.
Yep. Okay. So that's kind of the basics of paying federal income taxes. But we have multiple systems of government here in America, and so the other thing that we often have to pay is taxes to the state as well. Okay. And so, depending on what state you live in, and every state is actually, quite different, which is, really fascinating. The state can also tax something from you as well. Okay. And so there's some states that have 0% income tax, or some that have up to 10%. So I think at the time when I wrote these notes, the California state income tax was actually 10%. Okay. But one nice thing about the American tax system is that, when you pay state income taxes, you pay the state first. But then, it kind of happens in stages. So the state will tax you first, and then on whatever's left, the feds will kind of tax you on whatever's left. Okay. And so what that means is that, when you pay state income taxes, you can deduct that from your taxable income, from your federal taxable income. Okay. And so another way you can say that is you pay taxes to the state first, and then you pay taxes to the feds after that. Okay. And so just a very quick example. Okay. And so let's say that you have a design firm that made $100,000 gross income. And so let's say that this design firm lives in a state, so it could be in California, or actually Pennsylvania has a pretty high state income tax too. of 10%. Okay. And so in addition to this, let's assume that we have a 21% federal income tax. Okay. And so let's compute how much taxes that this company has to pay towards the state and towards the feds. Okay. So let's do the state first. And so the state, in order to compute this, we're going to take our 100,000, and let's assume that we have no labor or maintenance or materials costs. Okay. We're going to multiply by the state income tax rate, which is 10%. And so that's going to be $10,000. Okay. And so now that we've already paid that $10,000 to the state, you know, we don't have to pay we don't have to kind of pay taxes on this again to the feds. Okay? And so our federal taxable income will be our original gross income minus the state tax. Okay. And so that's going to be 100,000 minus 10,000. Okay. And so this is 90,000. And so our federal income tax is going to be our 90,000 here. Okay, multiplied by our federal tax rate, which is 0.21, and then that's going to be 18,900. Okay. And so it's not that, you know, when you have a case where you have both state income tax and federal income tax, you know, it's not as bad where you kind of add both percentages together, and that's how much taxes you pay. First, you pay taxes on the state, and then on whatever's left, the federal is going to tax that. So it's actually slightly less than, you know, just the simple addition of the two percentages. And so if you add these two guys up together, that's 28,900, and so that's about 28.9% of their original gross income. So that's a little bit better than just adding the two percentages, which is you would get 31% tax. Okay, any questions on this? Okay, and so that's the basics of taxes. So I think from here, you know, we'll pick this up on Tuesday and talk about depreciation. Okay? And so, you know, for those of you guys who weren't here at the beginning of the class, the scores for the midterm are up, so please take a look at those. The average was 43 out of 50. And I want to make a correction on question 2. And so question 2 basically was a very poorly worded question for what I want you to get out of it. So, you know, I've gotten a lot of feedback from you guys about, you know, the wording was confusing and, you know, and stuff like that. So I want to give you guys a chance to redo that problem. And so if you didn't get full credit on problem 2 on question 2 on the midterm, you can email me your revised response to it, and then I'll go in and I'll revise everyone's scores for it after that. Okay? And so I apologize for that question. You know, my intent with that was not to be tricky. It was just you know, it didn't have the effect that I wanted to. So it was, you know, that was something that was my mistake and my bad. So, you know, I want to give you guys a chance to get those points back, because it's because I agree with a lot of you that it wasn't really fair to kind of take points off when the question wasn't clear about what I wanted you to do. So so if you want to do that, definitely email me before this weekend, and I'll go revise your score. The minute paper for this week isn't up yet, so I'm going to put that up. And so for this minute paper, you know, I want to do something a little bit different, because we're at about the midway point of the semester. And so I kind of want to just check in on seeing, you know, how the class is going for you guys. So I'm just going to have one question on there, just say, you know, how's the class going, and just anything that you guys think that I can do from my end to make it a better experience for the second half. Okay? So thank you everybody for tuning in today. Have a great weekend, and I'll see you guys on Tuesday. Yes, the resubmission is sometime before Sunday. So I plan to do the regrades on Sunday afternoon. So if you can get it to me by Saturday, you know, that'd be perfect.
I also looked to see which problems I got wrong, and I couldn't find where that is.
Okay, I think I didn't enable it until like yesterday afternoon. So if you go check back to the Canvas site and you click the midterm again, you should be able to see all the problems and the feedback. And if you still can't look at that, then just let me know, and I can help you out with that as well.
Okay.
Do we get a gold star if we got number 2 right?
I'm sure. I can. I'll give you a high five and a handshake next time I see you. How about
Sweet. I'll take it.
that? All right. Thank you, everybody. Have a good weekend.
Hey, Professor, the office hours from 4 to 5:30 today, correct?
That's correct. Yep. So there'll be office hours 4 to 5:30.
I forgot to ask, is this just for 401 or is it also for fluids?
It's for anything. So you can come in and ask for. So I share office hours with all my classes. So if you want to talk about that, we can even talk about like career stuff, or that's basically my time for you guys, and we can talk about whatever there.
Okay, cool. Because I have a question that's totally not related to class. but it's
Okay.
related to
Yeah.
fluids.
Okay. Yeah. Sure.
All right. Thank you. I'll see you at 4, I guess.
Okay. Yeah. I'll see you at 4.
Okay, bye.
Bye. Yeah, I teach fluids. So I teach the 830 section of fluids. And so if you have questions on that, even if you're not in my section, you can come ask questions. Last year I was answering questions for several different fluid sections. So if I could be of help, then I'd be happy to help.
Professor,
Yeah.
why do homeowners keep on paying tax after they pay off their houses?
Yeah, so that's tax to the city. So that's not tax on the house, but it's more tax on the land that your house is on, basically. So that's basically taxes to the city to basically make use of that land. So it's maybe not on the tax on the house itself, but it's on the land.
So when you buy a house, you don't buy the house with the property. You only buy literally the house.
You buy the house and you buy just the house, but then the land that the house is on, also you have to pay taxes on that. So it's not like you're buying the land, but you're also kind of paying for that land through taxes. Yeah. It's complicated. I can't claim that I fully understand everything too, but that's just kind of how I understand it. Just from this point in my life right now. Yeah.
So technically, you can never really own land.
Correct. Yes.
Okay. Thank you.
Mm-hmm.